bytes. Okay, and there are two abstract classes called input stream and output stream for reading bytes or writing bytes respectively. So input stream is used for reading byte streams, and output stream is used for writing byte streams. So byte streams is basically raw bytes. Bytes are your every byte is like 8 bits, right? Which comprises of zeros and ones. And characters, and then there is a classes which are associated with character streams, and there are two abstract classes called reader and writer which deal with character streams. With character streams, the bytes get interpreted as characters, like ASCII characters or Unicode characters, or it all depends on the character set that you're using. And the methods for reading and writing data from byte streams and character streams are quite similar. They have same names also, most of them. So both the reader and the writer classes, they read and write 16-bit Unicode characters. If you are a software developer, you should always know what Unicode means. Unicode lets you read characters from different languages. Like you can, in Chinese there are like so many different characters. In Hindi there are different characters. In Spanish there are different characters. Right? The keyboard that you see here, you just see English characters. But if you go to China, you will see a different kind of a keyboard with different kinds of characters, right? So you need, with 16 bits, you can represent up to 2 to the power of 16 characters, which is a very large number. And this number is good enough to represent all languages all over the world. So it's extremely important that you understand what Unicode means. So you use 16 bits for Unicode characters, and they can cover a character from every language in this world. And the input stream and the output stream classes, they read and write 8-bit bytes. So the reader and writer are character stream classes, and they can read and write 16-bit Unicode characters. And the input stream and output stream classes, they deal with byte streams, and they can read and write 8-bit bytes. So we have these four classes which are all abstract classes. Two for readers and writers, which is for character streams, and two for byte streams, which is the input stream and output stream. And then the Java IO package has a large number of derived classes which derive from either the readers and writers or the input stream and the output stream classes. And then the derived class that you use, the way it works is there's a design pattern called the decorator pattern. In the decorator pattern, you wrap an object inside another object, and the new object gets additional responsibilities. I'll explain this with an example a little later. So we have a large number of derived classes. So how do you choose the correct implementation? So the questions that you need to ask yourself is, what is the format of the file that I want to read or write? Is it text or is it binary? Do you want to access the file in a random access fashion? Are you using objects or primitive types? And what are your sources and sinks of data? When you read and write, it may not be just files in your file system. It could be like sockets, where you open a network connection and read from the socket or write to the socket. Or it could be files, or it could be strings, or it could be an array of characters. So your sources and sinks of data may not be just files in the file system. Okay. And then do you need to use filtering techniques like buffering? Buffering lets you buffer reads and writes. So it makes it more efficient. So instead of trying to read every bit or every character, you read a bunch of characters or a bunch of bytes. And that's what buffering provides you. So the byte stream abstract classes, you have the input stream, which is a byte reader, and you have the output stream, which is a byte writer. So the important methods here are read, skip. Read will read a single character, write will write a single byte. Skip will skip a specified number of bytes, okay, and close will close the stream. You should always close it in a finally block, because close itself can throw an exception. Okay, and then for character streams, the abstract classes are reader and writer, and if you see, they all have similar methods. So the reader also has read, skip, mark, reset, and close, and writer has write, flush, close. So if you go to the previous slide where we looked at the byte stream abstract classes, you see that the methods are quite similar. But the only thing difference is the byte streams will deal with bytes, and character stream abstract classes deal with characters. So the byte stream concrete classes, you have, these are all the different derived classes for the byte stream concrete classes. So you have the file input stream and file output stream. You have the buffered input stream, buffered output stream. Okay, and so on. You can look at the documentation of all these classes in the JDK API. So you look at in the JDK API, in the java.io package. So let's go to the Java IO package. And you'll see all the different interfaces and the classes that are available. So all these classes that I'm talking to you, you can read the documentation of this from the JDK API. And similarly, you have derived classes for the character stream classes. So here you have file reader, file writer, buffered reader, buffered writer, and so on. I mentioned earlier about using the decorator pattern when you want to do something with reading and or writing. So let's take an example. Let's say you want to read each line from a file. So what you do is you use a buffered reader. First, what you do is you take the file input stream and read bytes from a file. But just raw bytes are useless for you. You want to convert those raw bytes into characters, and that's where this input stream reader comes in. Once you have read it into characters, you want to read those characters line by line. So you wrap this input stream reader in a buffered reader. So the way it works is you wrap an input stream reader over a file output stream or a file output stream. So you create a file input stream object and wrap it inside a input stream reader. Then you wrap a buffered reader over the input stream reader so that you can read one line at a time instead of character by character. So the buffered reader, let's look at this. The file input stream, it obtains the bytes from a file in a file system, but just raw bytes are useless. Then you use an input stream reader which will convert those byte streams to character streams. So it will read the bytes and decode them into characters using a specified character set. So once you have converted them to characters, you want to read that text of characters line by line. So you are reading the text from a character input stream, buffering the characters so that you can read it by line by line. So let's look at an example of this. So here I have a class, a demo example program, which is trying to read from a file called status.txt in c:temp. It is c:\temp/status.txt. We have to use two backslashes because backslash is a special character and you want to escape it. So I'm reading this file. So the first thing I do is I create a file input stream on this my file, which I have. This is the file object, is just represents the path to a file on the file system. So I'm creating a file input stream and I want to reinterpret those as UTF-8 using the UTF-8 character set. So this guy will read the file in the form of bytes. Then you wrap this inside an input stream reader which will convert those bytes into characters. And then finally you wrap this inside a buffered reader so that you can read the characters line by line. And finally, when you have this object called in, what you do is you read it in a loop by calling the read line, and you keep doing it while the read line is not null. It will become null when you reach the end of the file, and then you read each line and then you just print it out. Okay, so this demo buffer reader, let's run this program, and here it is reading each line from this file and printing it out. Okay, and then I'm putting this entire thing in a try catch block, and I'm catching all kinds of exceptions. Okay, so whenever you do IO, you should always do exception handling, and the constructors and the methods of the IO class can all throw a checked exception, and the checked exception is of type IO exception. It belongs to the Java IO package, and the base class for all the exceptions for IO exceptions is IO exception. There can be different kinds of exceptions of this type. Okay, like you can have like a file not found exception and so on. And then finally, whenever you close a stream, you should always do it in the finally block, because the close itself can throw an exception. Okay, so let's try to run that program again. Let's look at that program, and here you'll see that it is throwing all kinds of exceptions. Let's say I'll say status11.txt. We don't have a file called status11.txt. So if I run this program, it says the system cannot find the file specified, and that is coming because we have caught that exception. Okay, and if you notice here, the most specific exception always comes first, so you should always put the exception at the very end, because every IO exception is of type exception. So this was an example of reading files and printing out each line of the file. Similarly, you can use the same concept when you try to write to a file. Okay, so this briefly covers some of the important classes in the Java IO package.